I
We're
think
live.
YouTube's working. Hang on, let me just
Check in.
let me check it too.
Yeah. Can you guys check on Twitter? Yep.
Yeah, it's working.
Perfect. Awesome.
Just a second. I think it's working fine on you.
Yep.
Yeah, YouTube's
On my
working.
side,
Yeah,
it's working.
YouTube's
Okay, we
working
should
too.
start.
Yes, let's go.
But we're supposed to tweet about it, right? Aren't we?
I did.
Yeah, I retweeted it.
Okay.
That's fine.
Okay.
You can do that too.
Just give me a second. I'll get that done. And let me, while I'm at it, I'll also share the YouTube link. Because
Yeah.
why not?
Did.
Yeah.
Just a second. Okay, so Raza basically made a reply to your tweet, and yeah, you guys can just retweet that, and I think that's it. We can get started.
Okay.
All right.
Okay.
Perfect.
Okay, so I think we should brief people. Like there might be people who may not have joined us last time, so I think we should let them know what we're doing and what's the plan for today, right?
Yep.
Yeah. I think that important to note that last time we played with Datagran, which is an amazing tool to deploy your machine learning models, do ML ops, and they've got insane features to connect data sources. So we explored by connecting a couple of data sources and actually ran a model. Today we're going to take it to the next level where we're actually going to have a look deeper into a train model and also drifting. Did I say that correct, Prashant? Drifting, right?
Yeah, we're going to look at two functionalities like uploading custom models and also handling data drift. So yeah, we would be checking that out.
Cool. Well, without further ado, let's get started, and feel free to check out the previous session on
Yeah, we'll link it in the
Yeah,
description
I'll
as
link
well.
it below Raza's tweet after we're done with this session. So after you see this, you can go check that out, and yeah.
Yeah,
We're good
so
to go.
I think like before starting with the second problem, I think we can just show them the interface again of the Datagran and what we did last time to show the pipeline. So yeah, basically, yeah, this is Datagran. So what you can do on Datagran, it's mostly a no-code platform. So you don't need much like high technical skills to build machine learning pipelines end to end. You can drag and drop stuff, connect different things, and it should be like fine. And it's also scalable, so you don't need to worry like about anything that you might generally do on like a cloud platform like AWS or GCP. So you can create pipelines just by dragging and dropping, and yeah, it does most of the things on its own. Like you can see, adding different data sources, creating models, training models, and all. Like you can redirect your outputs as well. You want to get something, some updates on Slack, get the data on mail, and all those things. So like fully automated stuff mostly. So in the last stream, what we did was that, let me log in and we can show. Yep. So yeah, basically this is our workspace. I think we worked on it last time, this the demo stream one. And these are the data integrations where we can add data from different sources. And yeah, just team member stuff. And this is the custom model one. So let me open the last workspace.
So suppose just to kind of like give a quick recap, we tested out some of the
Yeah.
basic features of Datagran. We trained a model. We pre-trained it. We uploaded it to Datagran. We connected lots of data sources, and we made an API out of it that we could use anywhere, right? So
Yeah, and I think
exactly.
it's pretty important to know that, it might seem like a simple process, but anyone who has worked with this kind of stuff, like from simple things such as folder structures, like managing a directory, to manage version controls on data, this actually simplifies it. And I think the most annoying part is that it's never visual, and visualizing this whole
Yeah.
process end to end is like game changer.
Yep. And I think like this is the pipeline that we created last time. So we like took the Titanic data problem, we split the data set, we trained a classifier or random forest classifier, and this is like available all in here. So we just picked that and it's like Spark implemented algorithms and yeah, just got the metrics and the results and also a REST API. So like in here we like you like connected the data sources, we trained a model here as well and like did everything end to end. And like in this stream what we're going to do is that we are going to explore a different feature, which is say if you don't want to train your models on here and you already have a like scikit-learn pipeline, you already have trained models. So what you can do is that you can upload those custom models over here, connect your testing pipelines or your inference pipelines and just get the predictions from there. And like you don't want to, if like you don't want to train your model here, you can also upload custom models. So that's exactly what we're going to do today. We're gonna like pick up a sample data set and yeah, do it end to end, build a model, upload it and get inferences from it. And we can also look some of the other features like as we go along. So I think we
Prashant,
can, yeah,
just one thing before you go. So just increase the zoom of the browser, like so.
yeah, sure. Oh, like overall browser or just the
Yeah,
pipeline?
the overall browser, because there are
Okay,
things on the
yeah.
side also. Yeah, just by a little bit.
Is it better or a little more?
No, I will keep
don't.
it like this.
Okay, keep it like this. Fine, sure.
Okay, let me know like if I need to like zoom out or more.
I
Okay,
don't think it changed,
so
but it's fine. Yeah.
no, that's fine. I can increase one more bit.
Okay,
Is
yeah,
it
now
visible?
it's
Fine?
perfect. Perfect,
Okay,
perfect. Yeah.
Okay, so I think we can head over to Colab and yeah, create a model there.
So Google Colab is basically, it's an online IDE where you can write Python code, and you can, it's mostly from training machine learning models because you get a free GPU, and it's in the cloud and it's really convenient. So yeah. What model are we training? What's the data set?
Yeah, so
Yeah.
like it's basically it's not very complex data set, but it's a heart attack prediction data set. Also a classification problem. So it has like medical features like age, sex, and other things. So yeah, that's what we're going to do. We're gonna classify it over here, train the model, and save it and upload it, and we can see the procedure how to do that exactly. So yeah, let's import the libraries first. I don't think we would need plotting libraries, but just in case.
Yep. So we're importing pandas to import the dataset, NumPy to change the shape and stuff of the dataset, Matplotlib and Seaborn are to visualize the dataset, I suppose, and warnings just give you a warning if something's wrong in the code, right?
Yeah, like
That should be.
what happens most of the time, like when you're reassigning, like the pandas give some kind of warning. So just to like make it more pretty and keep out the warnings. Okay, so I'm gonna upload the data set from my local machine. Like if the data set is available on Kaggle and I've pulled it from there, and also the information about the data set as well, about the features, because they are mostly medical features. So like it's hard to understand now, like out of the box what they do. So okay, so I think yeah, the CSV uploaded, we can read it.
So DF stands for data frame. Basically, we're importing the data into Python so that we can play with it. Yeah.
Let's get the shape and also the head.
And the shape is basically how the data is structured, like how many columns and rows does it have. So we can see it has 303 rows, I believe, right? And 14 columns. Yeah. And then
Yeah,
df.head gives you like, some think of it as a spreadsheet, and d of that head gives you like the top five, the first five,
Yeah, by
ele- uh,
default it gives top five. You can customize that as well. So
exactly. Yeah.
yep. And okay, I have some information from Kaggle about the dataset. Let's pull it over here. Okay, so yeah, this is the description. Age, we know the age, sex, and yeah, these are some of the, I think, yeah, these are categorical features. And yeah, so like most of the stuff I I don't understand, but like that's fine. Like we don't need that. Yeah, we just need to know the output right now. So we're gonna, like, we're not gonna do extensive feature selection and stuff. We're just gonna take them like as they come. Just need the just the important scaling part and the training the model, because that's like the aim is to just you like how to use Datagran with this. So yeah, we can just move ahead. uh, let's just add the columns that we have category. We have category columns like, okay, sex would be a category column. This has four kind of values. This would be as well, and this would be as well. So yeah, let's add all of them. I think this is also categorical column. So we can add this. Uh,
So cat is like we're basic. So like there's lots of data in this data set, and it's in categories, right? So there's like, as
yeah,
Prashant explained, there's the sex. There is different things that you can use to predict whether someone will get an heart attack or not. So we're just putting that in a list so that it becomes easier to work with. Prashant, you put a dot instead of a comma after rest ECG.
yeah,
Yeah,
yeah, got it.
awesome. Yeah. And the con columns, like these are the these are numerical
Continuous
data.
one. Yeah,
Numerical data, right? Yeah, yeah.
yeah, yeah. Okay, I yeah, just two more, I guess.
So the
And
thing about machine learning models is that they only understand numbers. Really, they don't know what male or what female is. So you'll have to represent it in other ways, so that machine learning model can interpret it, and the machine learning model only understands numbers. So we'll have to use a few techniques to get that done for the categorical columns.
yeah,
So yeah.
let's see if any, like, do we have any misspells or something. Okay, so yeah, this is selecting the category ones, and yep, it's fine. So let's move ahead. Let's we can look at the count as well, like how many unique counts we have, just as an information. And let's do take I equals to PFI dot value counts, and that should be shape. Okay, this should give us the data frame.
So we're just looping over all the columns that there are, and
Yeah. Okay. Just
yeah.
let's just make it vertical. T stands for transpose, so it's just gonna move the table like vertically. Yep. So we're just iterating over each of the columns. We're just doing the value counts and getting the unique values only. So yeah, age 41 unique counts. Okay, we have 41 different
Yeah,
ages.
basically
Sex 2.
we're looking at the values that
Yeah.
are the what do you say values that are not the same in each column that are unique.
Yeah,
Basically, that's
just the
yeah,
distinct values here mostly.
yeah.
Okay, let's just do a short summary describing the data set as well. We can see the like the about the continuous columns. We can see the mean, median, and like the percentile as well. So it's like we can do it using the describe method from pandas, and yeah, let's do it transpose as well. Yeah, so you can see like if you have continuous columns, you can look at the different percentiles, 25, 50, 75, the maximum values as well, mean and standard deviations too. And also we like one important part, we also want to check out the like what kind of columns are there, like if even the numeric columns are being parsed as strings or not. So that should not be the case. And okay, so and you can see we have 303 values in all of them, and that's the shape of the data as well. So that would suggest that we don't have any missing values, so that's a good thing. And also all the d types are int and float 64, so I don't think we need any kind of like conversion. So yeah, everything is passed correctly. We have all the numbers, so all of this are int and 10 float, so this should be fine.
Yeah, it's
We
good
can,
to
yeah,
it's
yeah,
good
go
to
ahead.
point out that it's good to point out that if we had a string, it could throw an error in the model. So it's
Yeah,
important that it's either an integer or a float. But considering that that's the case, I think it's usable for Datagran. That's important.
let's look at the Pearson correlation as well, because we just want to see like if anything like pops out that we might not want to use in our data set.
So this is all, data cleaning. We're just trying to make sure that we clean the data before we pass it to the model.
Yeah, just like with actually any machine learning model exercise that you would do.
Yeah, and this is the correlation matrix also. I would like, I always prefer using like some kind of heat map to do this, because it's just like it looks prettier. And also like, and with the colors it's like much easier to like look at the correlations, go over and see if anything is like that is highly correlated or something, rather than looking at each of the numbers separately. So let's just do, and I'm just using the code that I like most like normally use, this kind of code snippet to like do this like plotting the correlation matrix. So it's like just easier to see, the more readable to the eyes. So we're just, what we're going here is that when we create a correlation matrix, we're gonna make the upper triangle, the like the part above the above the diagonal to the right side, we're gonna make that like entirely blank, because the values duplicate over there. So you could just go look at all the correlations within the left triangle. So what this nptriu is just like making those all the values one and zeros. So yeah, let's do it. If and yeah, let's do the plotting now. These are just very specific arguments that we use to like make it slightly more better. Like anode equals to true does like puts in the value in the respective squares, so you could see what value is it rather than just the color. CMap just uses a different color palette that we want to use, so we can put something like YL, and BU, which would mean yellow, green, and blue. So it's gonna use that color pattern with that. And yeah, just want to add some text over there. So like if we, in case we like save the plot or something like that, we do have some kind of heading that gets saved with the image. So yeah, we can do that, and maybe increase the font size a bit. It should work. Yeah, let's put a here as well. Okay, so you can see, yeah, we can see the correlation as well. So nothing very significant, although I think this feature, whatever it is, thal ACHH, like it's like on the negative, like negative correlation, which, and 0.4 is quite significant. But yeah, so like, yeah, we can, right now we're just gonna go ahead with that. And okay, so we have done all of this, and we can just, I think right now, train a model. I'm just gonna try two most common algorithms, and we can try classification, we can try random forest, and we can try probably an SVM, and see which one, like whichever stands out better, we can use that, go ahead with the model. And we're just gonna add scaling as well, just in case anything comes up. So yeah, let's do the imports for the scaling. And for the splitting,
So we're trying to, normalize some of the values in the dataset so that we don't have any outliers. And we're also splitting it into training and testing datasets. So one part of the dataset we'll use to train the model, and the other one we'll use for testing it. And we're using a support
support
vector machine. Yeah.
and we're going to import support vector like classification from there and a random forest. So yeah, and let's import some metrics as well to get the calc accuracy and all that.
Yep, so that we know how our model is going to work. Yeah.
Yeah, just as a sanity check in over here. Classification. Yep. And okay. We're not going to do the ROC because that's fine. Okay, so we have the columns defined as well, categorical and continuous. Let's just define the features as well as the like the target variable. So okay, so for the features, we're gonna have to drop the output column so that we only have the features in here. And in the Y, that would be the target only. So we're just gonna do, yeah. Let's see if we get them. Yep. So we got all the features. Let's look at the target as well. Yep, target is fine too. Okay. So let's just initialize the scalar. And split the data set.
Yep. So we're just splitting it into training and testing data sets. Yeah, we're using the train test split function that we just imported above.
Let's just do the test size. Let's do 25%. So 0.25 would mean that 75% of the observations would be used towards training and 25% of
Yep.
observations would be used for testing purpose. And random state would just like if you put in a number, what's random state gonna do is that it's gonna split it exactly the same way, no matter how many times you run it. If you don't put a random state, it's gonna define a random state by itself internally, and each time you split it, you're gonna get a different kind of split. The rows would be different in each split, but random state makes sure that you get the same split, like in case you want reproducible results. So okay, so we can look at the shapes as well, like how much data we have in the training and testing split. Okay, so we have 227 observations, 13 columns for training, and 76 observations for testing. And yeah, this is for the target as well, one column for target. Yeah, same split. So this is fine. Now we can define our classifier. And yeah, so like what we're going to do is that in order to be able to work with Datagran, the model has to be a scalar pipeline. It can't just be a normal model. It has to be a scalar pipeline because pipeline makes sure that you can add scalar in like within the model itself. So what we're going to do is that we're going to import the scalar pipeline. We're going to add the scalar in the pipeline as well as the classifier, and we are going to export the pipeline. So in the model, you would get the scalar as well as the model as a pipeline, and then we can upload it to Datagran and get the inferences from it. Okay, so let's import the sklearn pipeline. Let's define. So first we're gonna need scalar. We defined the scalar, I guess, but yeah, let's redefine it again because we don't. Oh, okay, sorry. Where did it go? Okay, you should see it,
Yeah, it's
right?
fine. It's fine now. Yeah.
Yeah, okay.
So I'm assuming like an sklearn pipeline is basically whatever we just can't did above it does it here in like.
Yep. Yeah. So like in sklearn pipeline, you like it like combines all the components you have. Like if you have scalar or something like that, you can put all in the pipeline, and it's just easier to maintain than adding each component individually. So yeah. So just like here in a single pipeline, we're going to be adding scalar and classification. So you don't have to make sure every time like you're passing the data through the model that yeah you have to scale it as well and all the pre-processing steps. So yeah, we're just gonna build it within the pipeline. And okay, so we have defined the scalar. Now let's define the classifier as well. As we see, let's just put classifier as well. And we're gonna put SVC. There's a okay. We have argument something like kernel, so we can put linear. I guess linear is the most common one, and c equals to 1. I think that should be fine. Do we have any parentheses missing or jumping? Okay, I think there's one extra, right? Because I'm seeing it right now. This is closing over here, and this is closing over here. Do we have one more missing? No. Let's just do it. Right. This is one, and then we can do this one, and then we can do this one, and this should be fine. Oh, missing one.
Yeah, I
Where
think
is
you
it? Where
missed.
is it? This one is closing fine, and this one is closing fine. Where? Like, where is it? Where is it
I
missing?
think you put an extra one maybe right there. Yeah, just try.
But like the pipeline should be closing, right? So
I suppose just put it into one line so that we can better read it.
yeah, let's do it.
Okay, so
Yeah, this is the pipeline. This is the list, and this is for SVC. This is for
so for now, just get rid of all. On the right side, get rid of all the parentheses. Sorry, like yeah, and then
yep. We
go one by one.
no. The problem is not in the parentheses. Yeah, we misread.
Okay, Mr. Comma.
Yeah,
No,
this
there's still a problem.
should be fine.
Yep,
Yeah, that's fine. Yep.
it worked
worked.
now. Yeah.
Yep. This is how programming works, in case you were wondering. You make stupid mistake, you don't make big mistakes. And okay, so like the training model, like whether you train a model, whether you train a pipeline in sklearn, it's the same thing. So yeah, so just do it a pipeline fit. This should work. Okay, this is working. Now another thing that we need to do is that we need to export the test set so that we could get inferences on the test set, and then like we're gonna do rest of the stuff on Datagran. But yeah, the only thing we need to make sure is that we export the test set that we are going to like check the outputs on, and also we need to export the pipeline. And the final thing that we need is that we need the requirements file as well. So when we upload the model to Datagran, like it should know what dependencies are there for the model, so it can like get the environment set up for that. We don't need to explicitly install all the requirements, but we need to provide the requirements to it so it can use them. And so yeah, so we have to make a requirements file as well. But first, let's export the test set. And we can do is that we can combine the features and the target as well for the test set. And we are gonna need the target, not because in for the inferences we don't need the target, but we do need it for a data drift that we're going to explain why do we need it. But for the Datagran, like for the data drift feature in the Datagran, we are going to need the target as well. So we are going to export both of them, the target as well as features here. Let's just make sure indexes are fine. And yeah, let's just output it to CSV. Let's do hard test full.csv and make sure indexes are not saved. Okay, let's do this. Yep. And it should look fine. Yep. Okay, so we have it. Now let's export the model. Now the pipeline, in order to export the pipeline, what we can do, we can import something like joblib, and it should be pre-installed. I think it's a native library, and joblib can dump the model or dump the pipeline, both of them. So we can dump it and we can name it something like hard or model.dump. Okay, it's dumped as well, so we should see it over here. Yep, it's here. So final thing is writing the requirements file, and let's do, what do we need? We need pandas, we need numpy, and we need, although we don't need sklearn because we're just going to do the inferences for the matplotlib, sorry, but we're just add it for
Just in case. Yeah.
previously as well. Yeah. And okay, so like in case you don't know, you can use a magic function to write a pipe file. You can just do write file over here and do requirements.txt, and you should be seeing a file here as well. Okay, we have it. So all we need is the test set. We need the model. the pipeline and the requirements file. So let me download them locally so I can upload it over to Datagran, and then we're gonna head over there. Okay, let's download this as well.
So in a typical machine learning workflow, you'd be working on training the model, making sure it's perfect, and then you'd be you'd make like a REST API. You would have a pipeline, very complex pipeline that you would have to use to deploy a model. And in most cases, most companies don't even have a pipeline. They just push it
Yeah,
directly,
no,
like
like you need a separate team to in order to do that. I think. Do you see the screen? No, let me share.
I think Raza has like good insight over there, because Raza actually
Yeah,
used to
yeah,
manage like a group of data engineers who would work on this stuff, and yeah.
yeah, yeah.
Yeah, it's not only multiple teams like that manage this, but it's also because there are multiple teams, it's quite a tedious process. So you need to make sure you're in sync with each other, and by making sure you do it right now yourself actually makes the whole process a lot cleaner. Actually, that's a good point, Pratham.
Yeah.
Yep.
Okay, so like we are done training the model. Now let's add everything to Datagran. So first of all, we're going to need to add the data. And like although you can add it from several sources, Google Sheets is one of them. So we are going to do is add the Google Sheet. And first we'll need to upload it to Sheets. So let's upload it to Google Sheets. And then we can pull it from here to the Datagran platform. So yeah, let me put the file here.
So this is the model, right? If I'm not wrong.
No, this is the test set that we're going to like check the
Okay,
predictions on.
yeah, I got it.
Yeah.
Yeah.
Okay, so in order to like pull this file from here to Datagran, you don't need to make it shareable. All we need is that we need this ID because it's unique. So the platform would know that what file to pick. And yeah,
Mm-hmm.
let's add it. These are some sample data sets that are being pulled from Amazon Redshift. Like if I'm correct, I think this is Redshift. And
Which
okay,
is
so you
like
can see
a
the different. Yeah, it's also like a data store from Amazon.
yep.
Yeah, and okay, so like you can see like there are several sources. So like if in case you have a MongoDB server, you can add the account connection, host name, port, and you can pull the data from over there as well. But right now we don't have anything set up for this, so we're just going to pull it from Google Sheets. But in case like if you have the data, you can like pull it from Stripe, you can pull it from MongoDB and SQL servers as well. So yeah, so let's add it from Google Sheets. Let's name the sheets our test full. We're going to connect the Google account here and spreadsheet ID that we copied from here. Yep. So this is the unique ID. Now let's add it. Yep. It should pull it within a minute or something. And yeah, so this sheet, it's going to get pulled. These are all the features that we selected. And after that we're going to add the model as well and the requirements as well, and then we can like head over and add the components, drag and drop them, connect them so that we can test the pipeline end to end.
Mm-hmm.
And yeah, so one more thing, like when you pull the data from like when we are pulling the data, we add the data source, and then we need to use something like SQL operator in order to fetch the data from the source. So by default what Datagran does is that it pulls everything from like everything as a string. So we need to like cast them as well. We need to cast them to float or int, whatever it is. And okay, so data is pulled now. Okay, so this is the replication frequency. This means that in case you have a data source that gets updated in like after like frequently or something, so you can do a frequent pull from that. So you can do monthly, so every month it's going to pull the data again, or you could do hourly, you could do daily, depends on how frequent your database gets updated. But we
And
just
we
have
showed
one
this.
time. Yeah, go
Yeah,
ahead.
we showed this last time as well, and this is super handy when it comes to ops, because
Yeah,
we're only
yeah.
going to do it one time. But if you're going to deploy it actually in a runtime or production, your sources are going to get updated continuously, and your model needs to stay connected to those data sources. So this actually also again, it's like it really is a game changer in maintaining your model and maintaining your predictions really.
Yeah. So like what happens that when you have a live model in production, so like you have inferences coming in from like if you have a customer database or something, so you're gonna have the database updated like like daily or something. So you can keep running on your inferences while the database gets updated, because it's gonna refresh the sources. So yeah, so like inferencing and all that stuff like works very well with this. So okay, so we have like our extraction jobs completed. We get that we had the test set of 76 rows, and we got them like, yeah, it took 12 seconds to pull that up, and we should see, okay, we have all the rows completed. So now
Yep.
let's head back
I mean,
and
so you
add
can
the
see
model as
it.
well.
It took less than 15 seconds to import
Yeah.
everything, and it was all seamless. We didn't have to do anything. Like,
Yeah.
it's all perfect. Yeah.
So, okay. So this is like where you can upload model. Let me show it again. So you can add upload new model, and this is like the Titanic one that we have tested before. And okay, so let's name it heart model. Let's give it a version name. Yeah, let's do any of these. Okay, so now this is where the dump that we have created using JobLib, we can like get the pipeline dump from here. Let me pull it from the local machine. Heart dump. Yep, we got it. Okay, so yeah, they
This is
should come up.
basically the machine learning model that we trained.
Yeah, that
Yeah.
we have trained over there. In the last stream, we trained this model here as well, but in case we have some, like we have a model some from somewhere else, we can do that. And yeah, this is where we upload the model and the requirements file that's it's needed to set up the environment for the model. So we just need to provide that with the requirements. We have Python 3.8 as support. Now we need to add all the columns that we have. So I think we need to add all of these. This would be, okay, how many is it? 14. So we're gonna need add 13 columns in here. So let's do that.
Because it
Input
starts
columns.
from 0,
Yeah.
right? Yeah.
No, I think here the 0 isn't the case. It's like we have 14, but like one of them is target. So the model actually needs only 13 of them. So
Okay.
yeah,
Yeah.
this is why we're going to add the 13. Now, yeah, we have 13 over here. This is because the Datagran should know that what are the exact columns that the model requires. Like if you give it one more or one less, it's gonna throw an error. So we have to define what are the all the columns that it expects, right? So let me pull the column names. I think, yeah, let's do age
There was age, there
and
was. Yeah.
few more. This is a little tedious, but like it's one time thing. So once you've done it, you don't need to do it again. So we're gonna add all the columns here. Yeah, couple more to go. And yep, we're done. I think this is fine. Have we added everything? Yeah, we have. So let's do next. Let's add it to classification and diamond stream. This is, yep. So now we have added the data source. We have added the model as well. Now, and we have added the requirements files too. So now it's time to like create the entire pipeline, and then we can like see it running. So let's go back to the workspace.
Yep.
Now, yep, in the workspace, we go to demo stream. And yeah, so we should see the integration here as well. Yeah, we have the hard test, and yeah, we have the team members. That's fine. Pratham is not here. And yeah, this is the model. We have added the model here as well. And okay, this is the pipeline. So we can create a pipeline. Let's do a new pipeline. Okay, so this is the playground that you would say. These are all the sources you would see, all the operators that you need to add. And yeah, you can see we have the already made Spark algorithms as well. So if you want to train model, we can do that from this. We can also do recommendation of products. And other than that, these are the actions we can do. We can add a Slack. Maybe if you want to do some kind of trigger message or something that you want to add to Slack, you can do that. We can export the output files as well as CSV. We can do the REST API as well. And we're going to use a couple of them. So yeah, so let's start making the pipeline. First of all, we would
So,
need the
so
yeah, go
basically,
ahead.
what we're trying to do here is, so typically, I think Reza is like very experienced in this. Like he's managed teams that have done this. You're basically this is a full pipeline where you get the data from a source, you pass it through a machine learning model, and then you make an app out of it by deploying the model. It's a very tedious process. And over here, just by creating a simple flowchart with Datagran's tools, you can simply just do this entire process in a couple of clicks, as we're trying to show you here. So it's very presentable, it's very easy to use. It also looks really nice.
So as you can see, we can fetch the data using SQL query. We have added the data source, and we have added an SQL operator as well. So that SQL operator can use to select the columns that we need from the data. So so we like to feed the model for the inferencing. We don't need the output column, although we do have it in our data. So we have the output column, but we are not going to select it because the model doesn't require that. So so let's do the query. We're gonna select the columns that we need. Let's do row number. And okay, we're gonna need to cast and add all the features that we have, the 13 of them. We're gonna do some kind of copy paste in order to make sure that doesn't take a lot of time. Okay, so now let's replicate it 12 more times, right? And let's fill them with the actual features. Create sex and CP. Okay. Yeah. And all of them have to be float. They require to be float in order because the model needs numerical. So here we're just making sure that all of them are casted correctly. So let's add all of them.
So this is basic SQL stuff.
Yeah.
We're doing,
you can figure this much out. It's not that hard. You just need to select the columns and use a cast function. And I think since this is mostly a no-code platform almost, so this is kind of the most that coding that you need to do. And it's very basic. So you even if you're not that much technically sound, that you can still do this. Are we one shot? Are we done? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Well, I think we have one more missing. Did we miss something? Let me check. 8sec, CP, TRB, SD, FPS, REST ECG, and LAC, and EXG, all peak, SLP, CAA, L, and did I count them wrong? Do we have 13 or not?
Wait, so it starts from
CP.
Yeah.
We have H, we have sex, we have CP, TRT, BPS, CHOL. Do we have C? No, we don't have CHOL. Okay, that's what I missed. So let's add that. Yep. And these are all of them.
Yeah, that looks good. Yeah.
Let's just add. Okay, so so here we would select the output column, and let me show you why. So we're going to select the output. But since we have, while defining the model, we know that the model doesn't expect the output. So even though we feed it, it's not going to take it as an input, but it needs it for something else. So let's add it to. And okay, so we can since you won't know the operator name, so what you can do is that you can come over here. But okay, let me copy paste this, and let me connect it to the operator. Do we have it? Okay, so you should see the name here. Let's see. Yeah. Okay, so we have the data source, and this is a table name. So we can come over here, click this, and add. So okay, so we have it now. Now let's run this and make sure do we have everything ready or not. Yep. Okay, so we have all the features. Yeah.
It's all imported fine. Yeah.
Yeah. Okay. Yeah, we have all of them. So okay, that's fine. So yeah, let's do it. And in order to make sure everything runs fine, what you have to do, like when we add the component, we need to like click this play button. So before we add any more further components, it needs to make sure that the previous pipeline is working fine. So anything like doesn't go wrong in the later stages. So we need to like run them once to just a sanity check. And okay, so like where we have the data here ready, so we can add the model. So this is the custom model operator where we can add the pipeline. We have added the model as well in the data source, in the model source. So here we can define that model. And so we're going to use a custom model. Now let's add the configuration for that. So we have the list, we have the heart model that we uploaded. This is the sklearn pipeline that we created. Like if you have multiple versions, you can upload the multiple versions for the same model. And here you can select what model you want to put in production. The table that we're going to use is the one that is connected to, which is this one, this SQL single source. In case you have multiple, it's going to show up here and you can select the name. ID column is that like we have created this column ID. So what's going to happen is that when we see the final output, it could do what it could do is that it could group all the zeros and one predictions together. So this ID would make sure that you have the unique ID as well, so you know which prediction belongs to which row or which sample. So this ID is just as a unique identifier. And in the okay, so like these are the columns that we defined that the model expects. And in this case, table column match, we're going to match the columns from the SQL table that are coming. So it makes sure that the model feed the features model expect and the features that we are feeding through the SQL source are the same. So we're just going to do the same matches over here. Yeah, like we have this names, like same names, but in case you have different names, you can match them over here. So like just to make sure that everything works fine. And we have CAA and TEL, and that's it. Okay, so we have added the model. Now one more feature is that we have the new feature, which is retrain model. Now this is actually related to data drift. And like before I explain data drift, let's just do one thing. What retrain model is going to do is that we can define some kind of condition. Say we have a model, and over time the distribution of the data changes. So what would happen is that our prediction or our performance may get affected because of this. So in case what we do is that in case the accuracy of our pipeline goes below something, or we have some different metrics that goes below a certain threshold, we can add the feature to retrain that model on some data, so that we make sure that our model is not lagging behind much, the performance is up to par that we expect it to. So this is the exact data drift configuration. So like we can define a condition here. So say like we want something like if our model performance goes below 70, we want it to be retrained on new data or some other source that we might want to add. So like if we can do accuracy, we can choose if it goes below say 50%. What we're going to do is that we're gonna, and yeah, okay, so accuracy on this table, we just have one source here, so we're just going to add that. And for the output column, output, this is why I added the output, because we want to make sure that if the fall accuracy falls below 50% on the output column, we can retrain it on a table. You can add a different source here as well, but we're just going to add the same table. So what it's going to do is that if the accuracy and the performance goes below 50, it's going to retrain that same model that we uploaded. So in order to make sure that the performance is as expected. So let's save this. And okay, I should rename it as well. Yeah, this looks better. Let's save it and let's run this operator. Okay, while it's running, I can kind of describe what exactly drift means. So suppose you have something like say we are going to predict the salary of people who work from home and people who work from offices, right? So you might have a variable that says, okay, people who are who are working from home and who are not, you may have data. Say before COVID, the situation was something like this, I would say, right? So very few people were working work from home. But like say your model is trained on such data, whether the distribution was kind of like this, and say it's an important feature for the model in order to determine the work from home. But after COVID, the situation would change, right? We would have something like this, or like something even more extreme than that. So in case in case the variable is like highly important, the distribution has changed like vastly. So the performance of your model that was trained before COVID would get affected, right? So what data drift would do is that when the distribution changes, say, and because of this distribution, your accuracy falls below 50%, then we just define that if it goes below that, we can retrain this model on a different data set or any data source that we want to add, so that we make sure that this problem is eradicated and the model is like working fine again. And yeah, this is what we just did over here. And we have the model here and it's running. So soon as it runs fine, and yep, soon as it runs, we can add the output sources as well, and we can see its prediction. Now we can play with one of the operators more as well. I think, yeah, let's do a Slack one. So let me connect it to this output. And this is a Slack testing. I'm just showing you a demo how you could like how such kind of operators work. So I'm just going to add it to my Slack account. And like I have created the channel called ML. Let's do Prashant. And let's just do a testing message. This is a test. Do I have the Slack open here? Yep. Okay, so we have a channel, and in order to make the Slack work, you can add the integration. So, and you can go to the apps and add the Datagran. So this app is integrated in channel, so it would be able to send and receive messages from here. So let's try like whether it works or not. I'm not sure. Let's do. Okay, what's the required? The table is required. Wait. Okay. Let's do this. Let's try again. And do we receive a message or not? Do we receive it? Okay, yeah. This is the test. So yeah, so you can use this Slack operator for some kind of triggering that okay, like you can add it to the end of the pipeline. Say the pipeline is has completed running, something like this, and you could get your trigger message over Slack. So you don't need to like sit in front of the screen like waiting for it to finish. So yeah, so this is how you can use something like Slack operator, and there might be other operators as well that yeah you can explore, and they could be useful to the pipeline as well. So okay, so our model has like finished running. So now we can get inferences from this. So let's do add an SQL operator. Now we're going to fetch results from this. Yeah, so the output, yeah, let's remove the limit because we want all the predictions. Run the query and okay, here are our results. So you can see like all the zeros are stacked together, and if you go to the end, all the ones are stacked together. So what, like, since the outputs are shuffled, they are not in the order, but you have the row ID here as well to make sure that you have the corresponding sample, like what prediction it belongs to, what sample it belongs to. And okay, so this is fine. Now we can save it. So we have got the output from the model. Let's rename it as well in case. And this is fine. Once more, save it. And what we're going to do is that since we have the output, we can even do an API export. So like rather than you making like if you're doing this kind of stuff manually, what you would need to do is that you would keep the model add different routes to like maybe a Flask app or something, and then Flask app would be able to give you some kind of REST API, right? But in this scenario, what we're going to do, we are just going to drag and drop one operator, API exporter, and it could give a REST API for this entire pipeline, and we can get our inferences from here as well. So like if I do something like this, let's set this up. Okay, so we have the get inferences operator, the SQL operator, and we want the SQL output. And like if we have like multiple sources connected to this REST API, we can add more sources as well. Maybe like if we have 2-3 tables, we can add them as well. But we just have one, so let's just keep this at one. We're gonna save it, and okay, also save the pipeline. We can save the entire pipeline here. We can also run the entire pipeline at once here. Let's save it and let's run the REST API as well. So okay, so it's running. The pipeline is almost finished. So we would be able to see like if we can get outputs from the terminal as well.
So the REST API is also completed. Nice.
Okay, so the REST API is also completed. Yeah, so that pipeline is ready in case, yeah, this is the entire pipeline that we built. We added the data source, we queried the data, and this was just a Slack testing whether like it connects to Slack or not. And we have the custom model that we uploaded. We got the results from here as well, and we added the REST API as well. Now, like, okay, so we can test the REST API as well, and let's see the tab. Okay, this is the charts tab. In case you want to make any charts or something, you can do that from here. So here as well, we have like different kind of charts that like in case we might want to play, we can add it from here. And okay, so this is the REST API tab, and we have the different APIs that we have previously built. And I think I didn't name it, so this should be the one that works. Yeah, so this is the curl command. You can just hit that and get the data as output. So, okay, so I need the terminal. So let me reshare the terminal as well. Let me stop and share again. Okay, do you guys see the terminal?
Yep, we can see the terminal.
Okay, so like I've copied the curl command. Let's try hitting. This should work. Yep. Okay, so we got all the outputs and the ID should be there. Yes.
Yep.
Yeah, they are. Okay, so we have the ID. You can rename this from the SQL operator in case you want the column name to be something more readable. And okay, so this is like the output of that SQL table, the final fetching of the results, and we had the IDs and the outputs as well. So this is like how it works. Basically, you can upload the custom model and you can add the data source that you want to see. Maybe like if you have a streaming data, the live streaming data or something that you do, like something live predictions that you do, you can add that data and get the live inferences from here and use this kind of API to get those inferences to the output. And yep, basically it's just that much, like this is that easy. And yeah, we didn't have to do like much of the coding other than creating the model over there, and we just drag and dropped stuff and we had the entire pipeline ready. But in case you were wondering, like if you do something like this end to end using code, you would have to like it's going to take a lot more time, and it's you'll have to be make sure that it's scalable. You'll have to do the entire deployment as well. Also make sure like what kind of scaling configuration you're going to have, manage containers as well, create a Flask application for the REST API. But here we did everything basically in almost less than an hour, or at most an hour, I guess. So yep, it was quite easy. It was quite like awesome as well because it didn't
Yeah, I
take much of a
mean,
hassle to do anything.
like
Yeah.
as you mentioned, if we were to do this on our own, we'd have to set up our own server, set up like
Yeah,
the
exactly.
OS. Like it's a massive pain. Here, the database, everything, it's just from one place. In a couple of clicks, you can get started, and you write a couple of SQL queries, import some data, and yeah.
Yeah, for something like this, like even setting up the environment would take like a lot longer than this. So yeah, like if especially if you're any kind of organization that doesn't have a dedicated data team or dedicated ML ops team, you could use something like Datagran that works like really good, and yep, also scalable in all the capabilities. It works like really good, and yep, this is something you can check out. So I think that's about it, right?
And yeah, that's kind of all we wanted to show you for this video. But like we also had another video previously where we also played with Datagram. We figured out some of the basic things, and now we looked into some of the more custom functions like adding Slack integration and also retraining the model, basically data drift, and retraining the
Yeah.
model as it deteriorates, because models have to be maintained very frequently. And this just automates the process into a very nice GUI, and it makes the entire process just very much simpler.
Yeah, exactly. Was there any final words, or should we wrap this up?
No, guys, I think it's time to wrap it up. I actually want to thank everyone who joined, and I hope it's clear that
Yeah.
how easy to use this tool is. It's really about visualization and making it easy for you to govern your whole tool, so the maintenance about it. And if you guys have any questions, make sure you drop them in the comments down below.
Yeah, drop into the comments, and yeah, that's it, I
Yeah,
guess.
we'll
And
be checking it out, and yeah, thanks a lot for joining our stream, and
yeah,
yeah,
everyone who joined on the Friday night, yeah, thanks.
and we're going to talk
Right,
a
guys.
lot more about Datagran, do a lot more crazy cool things. But yeah, that's it for now, and
Yeah, maybe see you
awesome.
soon. Yeah, okay.